All right, this one is already in standard form. So we looked at different ways to approach these based on the format it's in, right? So one is if it's in standard form, we go back to our skills of like shifting left, right, all that stuff. And then the others, if it's quadratic, you have the option to put it into standard form or to use the negative b over 2a method. When you get your quiz, which is on Monday, there's going to be a question that forces you into standard form. So you're going to have to do complete this word that forces you into standard form. And then there's going to be another one given to you in quadratic form that you have the option to either put it in a standard form or use the negative b over 2a. My suggestion is to know both because there are times that one is easier over the other. If your middle term is even and there's nothing on the front, complete the square is not that bad. If it is odd or there's a number on the front, complete the square gets much more complicated. So I would say a negative b over 2a is easier in those scenarios, okay? So just be prepared to be able to go back and forth between the two. All right, so we know this is a shift to the right 4 and up 5, or the opposite of what follows the x, and what is by itself could be your vertex. Your intercepts, if I plug, let's start with the y-intercept. I plug 0 in for x, I get y equals 0 minus 4 squared plus 5, negative 4 squared plus 5, 16 plus 5, which is 21. So x and y-intercepts are what we're going to find. Y-intercept is 0, 21. The x-intercept, since it's already in standard form, I'm just going to use that even root property, which means I'm going to set it equal to 0. I'm going to isolate that 5, and if it was positive or negative, whatever that next step is, would be to square root both sides. Even root says put the plus and minus when you do an even root, okay? So because it's a negative 5, what's true about my x-intercepts? They're imaginary, which means there are none. Okay, so now my max and min come from the direction this is facing. Which direction would be this? Would this probably be facing? Up. It's going to have a minimum, and the minimum value is the k coordinate of your vertex, right? Or the y coordinate of your vertex, which is 5. Good. So if I go right 4 and up 5, I already know my graph would look like this, and it's going to point up. And is there a vertical stretch or shrink on this? No. So I literally just go up and out 1 in each direction. If you didn't remember your stretch and shrink, or you were unsure what to do with it, then you can plot a point. So I would have plugged in 1 to the left of my x vertex and 1 to the right. In both cases, you assume you get the same thing. It's not on here, but what would be your axis symmetry? X equals 4. Good. Make sure it's x equals, it has to be an equation. Questions? Yeah.
For number 3, would you just write 5?
Yep. Because it's an absolute. So last chapter, there was relative, right? Sometimes we went up and down, so there's more than one. So there could be, so that's why you had to give the x and the y. But with a parabola, there's only one. So we just need the k coordinate.
On the test, when it asks about the maximum min, do we just have to like write the number and then
Yep.
y equals?
Correct.
Okay.
Yep. All right, to our number 5a said to find the vertex of the equation. So now it's in, and I would say if you want it, we have to do standard form, so we could do this 2 different ways. I'm going to practice both ways. But if it just said find the vertex, then one option is to just put it in a standard form and find it from there. The other is a negative b over 2a. So if a is 4 and b is negative 4, I don't need c, but it would be 21. Then my negative b over 2a would be negative 4 over 2 times 4. And these cancel, and I end up with a positive 1 over 2. Or I could have multiplied it out and gotten, come on. I could have gotten 4 over 8, which is still 1/2. And that's the x coordinate of my vertex. You could do it. To find the y, I'm going to plug it back in. So everywhere there's an x, I'm going to put the 1/2. Hopefully it will catch up eventually. And I'd get 4 times a fourth minus 2 plus 21. The 1/4 and the 4 cancel. 1 minus 2 plus 21, which is 20. Vertex is 1/2 and 20. And this also tells you if it has a max or min. I mean, not if it, what the max or min value is, right? This parabola would open in which direction? Up. So it would have a min, and that min would be 20. B says put it into standard form. So the first thing I'm going to do is group together the 4x squared, the 4x and bump the 21 to the outside. Now I'm going to factor out the 4. It comes off of both terms. Now my b is that -1. I take that b, I'm going to ignore the sign because I'm going to square it, so I'm going to ignore it for now. I would do b divided by 2 squared. So 1 divided by 2 squared, or 1/4. I add the 1/4 in here, and normally I'd subtract it from the outside, but I have to multiply by 4 first in order I do that. Cancel through the 4s, and I'm subtracting 1. And I get 4x minus 1/2, because I square it first and square it last, put the sign from the middle, plus 20. And it would be f of x. You could also leave it as y equals, but this is the standard form of your equation. And I could use that to check the vertex I found the other way. That's 1/2 and 20, so it matches. Questions on that one? Okay, again, a lot of steps involved in that kind of stuff, so be really, really careful. And they're not all going to be pretty even numbers. You got to be able to handle the fractions and stuff. All right, so chapter 2, section 2, this is not part 2, this is part 1. Part 2 comes from part 1, okay? These are called polynomial and rational functions. So these are no longer just squared, so no longer just parabolas. These are the ones that kind of take on like a snake behavior. Goes up, comes down, goes up, comes down, that kind of a thing. We're going to learn about a lot of characteristics of them, okay? The first is that these all have to be continuous graphs. They will have a degree of 2 or higher, so it could be x squared, x to the third, x to the fourth, x to the fifth, and so on and so forth. But they are smooth and continuous, meaning that they're not going to have disjointed parts. You're not going to have a piecewise function. They won't have sharp edges. They are all going to be rounded curves, and there's no breaks. So you can literally stop and start your graph from left to right without lifting your stylus or your finger, however you're going to graph it, or your pencil if it was a piece of paper. So these are examples of what they could look like. On the left, this is what you could see, okay? Those shapes that start down, come up, go down, up again, doesn't matter how many times. What you won't see are things like this, okay? It won't start and stop like a piecewise function. It won't have a sharp edge like the one on the bottom right. The first kind of graph we're going to do is a monomial. Mono means 1. So this is something with one term or one variable with an exponent. And these take on the characteristics of your x squareds and your x cubes. So if your exponent on your original equation, so if it said x to the 6th, if that exponent is even and there's not another x, it's just x to the 6th. It could be plus or minus a constant, but other than that, it would be by itself. Then this graph resembles the graph of x squared, meaning both sides are going to go up left and right. And in between, it looks almost like a parabola, but around your vertex, it will look flatter. The higher the exponent, the flatter it is around the origin. If that exponent is odd, like an x to the 5th, then it's going to resemble the graph of an x cubed, which goes up to the right and down to the left. And again, the higher the exponent, the flatter it is around the origin. So it literally just like almost makes it look horizontal right around the origin. And these, we're just going to approximate what these graphs look like. They don't have to be perfect. All right, so this one just says sketch the graph. And again, these are going to be approximation. But A is x to the 7th. Is 7 even or odd? Takes on the characteristics of our cubic function. It's going to point up to the right and down to the left. What would a plus 1 after the function normally do to it? Shifts it up 1. So I literally plot my point at 1, and I make it point up to the right and down to the left. And I don't need it to be perfect. I just need the overall shape. Now, if this was mapped, if I had like a multiple choice and this was mapped on top of another one that said x to the 3rd plus 1, then the only thing I would expect to see is that my third would grow faster in between here, and something with a higher exponent is going to flatten out a little bit just between the 0 and the 1 though. After that, my x to the 7th is going to grow faster, right? Because something raised to the 7th power is going to be bigger than something raised to the 3rd power. But in between the -1 and 1, I would expect it to be a little bit flatter, Okay, not a test question, not a quiz question, not something you have to worry about comparing those two. Just know that that's how it would look like. Now go to B. Exponent is even, which means it's going to resemble my parabolas, right? The minus one inside is causing what kind of shift? To the right one. So I literally go to the right one, I plot my point, and again, draw the parabola. In between the 1 and 2 and 1 and 0 would be flatter than if it was just squared, but outside of that, it's going to grow faster. All right, end behavior of a polynomial function, okay? It says end behavior, and that means what's happening on the left and the right. What are those arrows doing is what we're looking for. So end being at the start and the beginning, really. And they take on the same characteristics of your parent function. If your n is odd, now we're talking about highest exponent. If that highest exponent is odd, then it's going to follow the characteristics of your x to the third, which means it points up to the right and down to the left. I don't know what's happening in between those two, but at least I know it falls left and rises right. If that is an odd and it's got a negative in front, now it's reflected over the x-axis. So it's going to rise to the left and fall to the right. So this would be if it's positive, this would be if it's negative. Now if your exponent starts even, it's going to take on your characteristics of your parabola. If it's positive, they would both point up. And if it's negative, they both point down. So this is called the leading coefficient test. Instructions on a question might say, use the leading coefficient test to determine the end behavior of the function. And that's what it means, what's happening at the left and what's happening at the right. So we just said that but this is in words. Odd degree has opposite behavior. One's going up, one's going down. If it is odd and positive, it falls left and rises right. If it is odd and negative, it rises to the left and falls to the right. And even behavior, so odd has opposite. Think O and O. Even has the same behavior. If it's positive, both ends point up. If it's negative, both ends point down. If you forget, you can always fall back on your parent functions of x squared and x to the third. It will take on the same end behavior. Now it's really important to remember that this is of the highest exponent, and the highest exponent is not always first. If I had x plus x squared minus 3x to the third, I'm looking for the term that has the highest exponent, not necessarily the first. That exponent is odd, which means they have opposite directions. It's negative, which means this would rise left and fall right. So again, always highest exponent, not necessarily first. All right, example 3, use the leading coefficient test to determine the end behavior of the graph. Where's the highest one? What's the leading coefficient on the highest one? It's a -3. So the exponent degree would be 3. Leading coefficient is -3. So this takes on the situation we just said. It's odd, so they go in different directions. It's negative, so it rises left and falls right. All right, next thing we're going to find is the zeros of the function. We've done this like 4 times. Zeros are when I set the f of x equal to 0. We call these roots. Solutions, they on a graph will appear to be the x-intercept. They all mean the same thing. The differences for zeros, we will list the answers. So you can say x equals, but then if it's 1, 2, 3, you would list it like that. There will be factoring involved here. So like if I set it equal to 0, I would look to see if my function is factorable, factor it, split, and solve is what you would typically do. All right, so example 3 says find all the zeros of x to the third plus 2x squared minus 4x minus 8. It's already equal to 0. It may have started as equals f of x. You have to know to put that 0, okay? But now I have this function. How do I factor when there's 4 terms? Group them. Good. So from that first set of parentheses, what can I do? X squared comes out, and I get x plus 2. Second set of parentheses, what can I take out? Negative 4, and I get x plus 2. So then the x plus 2 is my greatest common factor. What's left over gets grouped together. And now you actually have 2 choices from here. One is split and solve as it is, but don't forget your even root property and putting that plus and minus when I move that 4. The other is x squared minus 4 is what kind of factorable binomial? It's the difference of 2 squares, which means I can factor it further, x plus 2, x minus 2. And then I split and solve. So I set each of these parentheses equal to 0, and I get x equals negative 2, x equals negative 2 again, and x equals positive 2. Now when I list these 0, I literally only need to list the unique ones. I don't have to list the other ones twice. It is important that it occurs twice, which we're going to talk about in a minute. But for the zeros themselves, we just list them. It would be x equals negative 2 and positive 2. So if I had put this on a graph, I would expect it to cross at negative 2 and positive 2. Still good? Questions? All right, so this is why it's important how many times something occurs. This is called multiplicity. The multiplicity of x-intercepts is how many times the root occurs. If my answer only occurs once, then my assumed multiplicity is 1 and I don't even have to state it. But if it occurs more than once, then I have to see, does it occur an even amount of times? So if something occurred twice or 4 times. Because if that happens, then the graph hits the x-axis and turns around at that point, or bounces off the axis. So it physically hits that point and turns around, goes back the way it came. If it's odd, then it crosses through the x-axis at that point. So if I had a graph and I had this 0 that occurs only once and this that occurs twice, then it's going to cross through this one. It's going to come up and hit and turn around and bounce off this one. So the left would be if it had an odd multiplicity. And the right would be if it had an even multiplicity. So bounces off is what that looks like. It's literally going to hit it. This is a 0, but it bounces off of it at that point. Okay, max turning points is next. And if a function is a polynomial function of a degree n, again, n represents the highest exponent, then the graph has at most n minus 1 turning points. Now it says at most, because it could have less than that, but it can't have more than that. So in the example that's here, it's hard to read, but that's an x to the 5th. 5 is the highest exponent on that function. So n is 5, which means it has 5 minus 1, or 4 max turning points. And if you look at the graph, it goes up, it comes down. That's 1 turning point. Down comes up. That's 2 turning points. 3 goes up, comes down. 4 goes down, comes up. So our turning points are our maximum and our minimums, our relative max and mins, where it goes up and comes back down again. And really, not so helpful on a test, more like if I graphed it and I compared it, did I graph too many turns, that kind of thing. Or if this was a standardized test and it gave you multiple choice, and maybe your exponent was to the fourth, and there were options in front of you that had 4 turning points or 5 turning points, you would know to eliminate those. All right. So it says, find the zeros, determine the multiplicity of each zero, and determine the maximum number of turning points. Use the graphing utility to verify. This question should look similar. We've already factored it. I put it, this is the one we did 3 slides ago, okay? When we factored it, we got x plus 2, x plus 2, and x minus 2. So we'll cheat because we already factored it. Which means our zeros were -2, -2, and +2. So when I ask, if it asks for the zeros with the multiplicity, if a zero only occurs once, we don't even need to list its multiplicity. It is implied that that is 1, okay? But when a zero occurs more than once, so like -2, then I literally just put like a little number next to it and I circle it. That means there are 2 of those numbers. If it was multiple choice, then it could say find the zeros in multiplicity, and it could say x equals 2 with a multiplicity of 1, x equals -2 with a multiplicity of 2. So you could say it in words like that. So now what does the next thing say? Determine the maximum number of turning points. How many turning points would this graph have? Max is 2 because it's n minus 1, okay? What would happen at my x equals 2 intercept? Is it going to bounce or cross? At 2, it's going to cross because it has an odd amount. At -2, it's going to bounce. What about end behavior? What's true about the end behavior of this? What's the highest exponent? 3, even or odd? Odd. Is it positive or negative? It's positive. So what's the end behavior? Falls left, rises right. Let's graph it. Here's what it should look like. So it falls left, rises right, which was true. It has 2 turning points. It can't have more than 2. At -2, it hit and turned around, so it bounced, and at +2, it crosses through. It's 1 less than the highest exponent. So the highest exponent was 3, the max it can have is 2.
How do you find out if it's like falling left and right?
So you go to the exponent, highest exponent if it's even odd. If it's odd, it's opposite. Positive, 1 right goes up, bottom goes down. Negative switches. And if it's even, both up or both down. All right, this is exactly what we talked about already. We've done this slide so many times. This is how to get zeros. So if you've never done your graphing utility, this is how you do it, but we've done it a million times. So this is a big chunk of how to graph from start to finish, okay? And I will tell you, I don't do all these things. I'll highlight, I don't even go in this order, but this is what your book recommends, okay? I always start with the first thing, which is the leading coefficient to determine your end behavior. So I want to know which way my arrows are going. Falls left, rises right, falls left, rises, falls both left and right, rises, whatever it is, you want to figure out your end behavior. Then I look for my x-intercept. So just like this said, look for your x-intercepts by setting f of x equal to 0. Determine the multiplicity. If it's even, it crosses or turns into, it hits the axis and turns around, which means bounces. If it's odd, it crosses through. The flattening out, you don't have to worry about too much because we're going to figure out extra points if we need it, but that is there. Then the y-intercept, you're going to find by plugging 0 in for x. And then I would say 4 and 5 are things that are optional ways to check your work. So I'm not going to ask you to tell me if it has the max turning points, okay? But if you graph something and you've turned it too many times, this is your way to check. And then symmetry is one of those things that can help you eliminate work. If I know it's symmetric to the y-axis, then I know what's happening on the right is reflected over the left, and I only have to do half the work. So those types of things will help you to graph these. All right, we're going to go 1 from start to finish. We'll see if we can get to the second one. I know you can't see the axis, but it's here. Okay, this says graph f of x equals x to the 4th minus 4x squared using what you've learned in this section. So we're going to kind of put it all together. First thing I want to do is figure out my end behavior. So what's the highest exponent? 4, even or odd? Even. Is the leading coefficient positive or negative? Positive. So if it's even and it's positive, what's my end behavior? Rises left and right. You could also write both up. That's fine. I know what you mean. Then I'm going to find my zeros. So I'm going to say 0 equals x to the 4th minus 4x squared. And I'm going to factor. Here I can take out an x squared. And I get x squared minus 4. And x squared minus 4 is the difference of two squares. So I get x squared times x plus 2 times x minus 2. And now I split and solve. I'm going to set this equal to 0. I'm going to set this equal to 0. And I'm going to set this equal to 0. Now, if I wanted to solve x squared equals 0 to get rid of that square, what are you going to have to do? You're going to square root it. When you square root something, what do you have to do in front of it? Plus or minus. Is there such a thing as plus or minus 0? They're the same, but that means there's two zeros. Up until this point, not important, but now why is it important that there's two zeros? It means it touches and turns or bounces because my multiplicity is 2. Does that make sense? So if we take an x squared out, it means there's 2 zeros. If we took an x to the 3rd out, 3 zeros. And then this gives me x equals negative 2. There's only one of those. And this gives me x equals positive 2. So I have a 0 at negative 2. I have a 0 at 0. I have a 0 at positive 2. And what are my arrows doing on the outsides? Both up. So I already know this is happening. Now, I could use intercepts if that was an option as a y-intercept, but if I take this guy and I plug zeros in, I just get 0. So my y-intercept doesn't help any further here. I already have it, okay? And this is where something like symmetry would help. How do you test for y-axis symmetry? Or test to see if something's even? What do you do? Make the x negative. So if I plug in a negative x and I raise it to the 4th, and I do a negative x and I square it, what's going to happen to both those negatives? They're going to go, well, they'll go back, right? They'll go back to the positive x to the 4th, and my equation would be the same as the original, which tells you this is symmetric. So whatever happens on the right-hand side of this graph is going to happen on the left-hand side of this graph. I know it has to cross through negative 2 and positive 2. And I know it has to bounce off of 0. What I don't know is how low I need to go in between. And the way you will determine that is plugging in 1 or negative 1. And if you didn't get the symmetry, you'd plug in both. If I plug in 1, for example, because that's the easier one, I get 1 minus 4, which is negative 3. And then I know I'm supposed to come all the way down here. Because it's symmetric, it's going to reflect over here. And then I know to connect those points. So when you are graphing, which this homework you have to graph by hand. I'm looking for it to be done by hand. You're looking for your intercepts, x and y. If you have two x-intercepts and there's a y-intercept between them, then you can use that as the point between. But for every other pair of x-intercepts, you have to plug in a point. There has to be a point in between there to see how high or low to make your turning point. Questions? Okay. Jay Pierce. All right, what was your end behavior? Falls left, rises right, because it's an exponent, right? An odd exponent positive on the front. You're going to take out the x squared, and I get x minus 9. And then x squared equals 0 and x minus 9 equals 0. There are 2 zeros and 1 9. So if I plot it, I get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are my two x-intercepts, okay? The 0 doubles as your y-intercept. I know it points down to the left, it rises right, it bounces off the 0, and then has to come back and cross through the 9. Now, how low you go is important. What you want to do is pick a point. When you have a big range like that, like from 0 to 9, pick middle-ish. It doesn't have to be 4.5, that's a nightmare. Pick 4 or 5, but you want to go about in the middle of those places and then plug it in. So let's say I did 4. I'd get 64 minus 9 times 16. 64 minus 144, which is negative 80, okay? I don't need you to go all the way down to negative 80. I need you to go down far enough so that you can actually plot it so it was 4, and then just plot a point and label it for negative 80. So again, I don't expect you to expand your graph that low. If you go off your graph, then you just have to make sure you label it, okay? And if you picked 5, that's fine too. It would have dipped down low enough that you wouldn't have known to come back up. Tonight's homework has graphs on it, and the directions on Canvas are a reminder that you have to graph them by hand. This is not going to be a test in which it's multiple choice graphs or you have your calculator for. You have to graph them by hand. Don't lose stupid points because you're not following instructions, okay? So this is kind of what I would expect to see. I'm going to go over those homework questions. So the first was the sign that they gave you the dimensions. These dimensions change, but this was one side, this is the other. So if you wanted to find the function that would represent the area, you would multiply these two things out. I would FOIL it out, and you would get this, negative 2x squared, God bless you, plus 104x minus 552. And then it said use the table feature to determine the max. You could just use the maximum. So if you go to graph this, and then you would hone in on the max by doing your left, right, center, you would find the x value is what it was looking for, not the y value. So it wanted to know what the x value was when it hit its highest point.